This is Specialist Guthrie here with another video. Last video we went over sort of the intuition about fractions, how to think of them, consider them for problems, how to compare them, and just kind of touched on what their uses were. I want to go over operations with fractions in this video. I'm going to go over just the basic ones, how to multiply, divide them, add and subtract them. So let's just get started. So multiplication of fractions works pretty straightforward. You multiply straight across. A times, if I had A over B times X over Y, those are two different fractions there. I would simply go A times X, those multiply, the bottom multiplies, B times Y. Whatever's on the bottom there. Whatever's there, multiply it straight across. It's a little bit simpler than addition and subtraction. We'll go over multiplication first, then we'll do division, then we'll do addition and subtraction, because you do have to incorporate some multiplication and division before you can add or subtract them. So that's why we're doing this first. So some examples, and we can probably see that you multiply straight across, given that we already know how to multiply regular numbers, such as 3 times 2. We know that 3 times 2 would get us 6, but can't ever represent 3 as 3 over 1. And can't ever represent 2 as 2 over 1. And I can represent 6 as 6 over 1. Okay, well then I still see it. 3 times 2 gets me 6. 1 times 1 is just 1. One group of one thing is just 1. So we can definitely see it based off other whole numbers there. But for the non-ridiculous answers, we can go, let's say we had 3/5 times 11 over 7. Okay. 3 times 11, and we can let you pause it for a second there. So if you wanted to pause it, that was great. Hopefully you got something like 33 over 35. Okay, let's try just one more. Just make sure we got it. About 8 times 4. Well, actually, I was already treating it like that. Let's go 8 over 5 times 4 over 6. All right. So I treat that like 8 times 4, 5 times 6 on the bottom, 32 over 30. It's okay to have a bigger number on top than on the bottom. We're not dealing with probability yet, not on this problem. This is called an improper fraction. If you ever have a bigger number on top than the bottom. So this number would actually be greater than 1. I mean, we can kind of see that with 8/5, that's bigger than 1. If I had 5/5, that would be 1. If I have more than that, I have more than 1. And 4/5, 4/6, that's a pretty big chunk of something. So it's not going to bring us quite below 1 yet. If we're to take another 4/6 of that, then yeah, it'd probably be below 1. But that's totally fine to do that. In the next video, I do want to go over in more detail on how to switch between improper fractions and mixed fractions. Again, more of that in the next video. All right, so what about division? Division can be kind of tricky. When we're simplifying fractions, we're going to do a slightly different method than we're going to do in this one. But bear with me for this, for the purpose of this video here. For division, we have A over B divided by X over Y. I'll use kind of the same conventions. So what I can do, this will be equal to A over B times Y over X, which is in turn just AY times BX. So this becomes this. So we switch the top and bottom, get multiplied, We flip it, and then we multiply. So for division, it's the reciprocal of it. In fact, the word reciprocal just means of a fraction. The reciprocal of a fraction is just that fraction flipped. 1/5 is the reciprocal of 5/1, or just 5. The reciprocal of 3/7 is 7/3. And the reciprocal of 8, yep, just the number 8, is 1/8. That's just going to be 8/1. So multiply by the reciprocal when you're dividing. And it's only the thing that you're dividing that flips. If you flip both of them, you would just have a completely different problem than what we started off with. All right, so let's look at a quick example of division now. Let's do a few regular examples. I had 3/5, 1/15, and 2/3 divided by 1/6. Okay, which one of these can I multiply straight across? And maybe I'll give you give me a minute. You can go ahead and pause this video, see if you can work both of these out. I won't have you simplify yet, but we'll do more of that in the next video. I just want to see if we can do the operations. So hopefully you pause the video and you're able to figure these out here. 3/5 times 1/15. That's just going to be 3 times 1, or 5 times 15, which is going to give me 3 over, let's see, if 5 times 10 would be 50, plus 5 times 5 is 25, so 75. So 3 over 75. Okay. Those are separate. So 2/3 divided by 1/6. Well, then I have to multiply by the reciprocal of that. So 2/3 stays the same. I flip this part. 6/1. So, well, can't you just, some people will be like, okay, can't you just go 2 times 6 and then have that 3 there? But the same people often get confused on what to do if they have 2 times 6 divided by 3. They sometimes get confused on that. Go ahead and just treat it like 6/1 for now. Multiply straight across, then see what you get. So 2 times 6 is 12. 3 times 1 is 3. Okay. And the essence behind simplifying a fraction once we get it is that once we have our quotient or a product, in this case 12/3, what's 12 divided by 3? It would be 4. So either one of those answers would be correct. If you got 4, great, you already know how to simplify things. We'll stick around for the rest of this video, see if there's anything else that we can improve on. Okay. All right, so I want to do addition and subtraction with fractions. All right, so let's start off pretty easy though. Let's go 1/5 plus 2/5. Well, if I had told you I had 1 bicycle, and then for Christmas, 2 family members both bought me a bicycle, so I had 1 bicycle, I got 2 bicycles for Christmas. How many bicycles do I have? I have 3. Well, I have a denomination of 5, not a denomination of bicycles. So instead of 3, I have 3/5. So 1/5 plus 2/5 is 3/5. That's for addition and subtraction. You make sure you have the same denominator, and then you can do your addition and subtraction. If I were to go 1/5 minus 2/5, of course that'd be a negative. It would be negative 1/5. If you don't know quite how to subtract a bigger number from a smaller one to get those negatives, there's a trick behind it. Maybe I can show you just real quick instead of making another video for that. If I have 4 minus 13, clearly that's going to make us go below 0 on our number line. It's going to make us go towards more towards negative infinity than we are towards positive infinity. Here's a little trick I like to do. I like to treat this like 13 minus 4, and then I just know, I keep it in the back of my mind that I am subtracting a bigger number minus a smaller one, so I know my answer is going to be negative. So whatever that is, I take the opposite of it. 3 minus 4 is 9. I just say, okay, I know it's going to be in the negatives. It'll be negative 9. You had 5 minus, or let's do a bigger one. Let's say 25 minus 75. Well, I know the difference between regular 25 and regular 75 is going to be 50. So when I'm counting down to 0, I count down 25. I take out a chunk of 25 from my 75. I have 50 more to go. So I'm going to treat that like 75 minus 25, 50. Oh, but I was subtracting a bigger number minus, or a smaller number minus a bigger number. So it's going to be negative 50. That's a short, easy trick to get you to the right answer quickly. On fractions, we know 1 minus 2. 1 minus 2, I treat that like 2 minus 1 to get 1. I was going the bigger number, or subtracting the bigger number, so it's going to be negative 1. So we treat that like negative 1/5. You are going to have to deal with some negatives on the ASVAB. Perhaps even some negative fractions. I don't want that to trip us up. That'd be kind of silly if we went through all that work and we got tripped up by a simple negative sign. It does happen. It's very unfortunate. And it does keep you from the kind of job you want. So if in our tutoring sessions you need to go over a lot of those, let me know. Maybe I can give you more problems like that. Or we can look on the PDF of word problems that I set up for you guys. Okay, so doing an operation when we have the same denominators, pretty straightforward. I know that if I had 3 over a minus 1 over a, it's going to be 2 over whatever that denomination is. A, it's not defined yet, it's just some amount. But if each a represents the same amount, that's going to be 2 of that. But what if it's different? What if we have different denominations? I was going to go 1/3 plus, let's say 1/4. What would that be? Well, now think of the denominations almost like units. 1 of something plus 1 of something else. Well, you can't really combine it. If I said I had one apple and 1 banana, I don't have 2 banapples, if that makes any sense. I can't just combine it like that. I do have to do some trickery. I do have to imagine 1/3 as a different fraction but equivalent fraction. As we know, there are equivalent fractions. In fact, every fraction that you can represent, and you can see, you can write down on paper, there are infinite equivalent fractions to it. So, what's a way I can write out 1/3? And here's a little trick for you too. I can double the top and bottom. I can go, okay, 2/6. Okay. If I were to put 1/3 into a calculator and type in 2 divided by 6 into a calculator, I would get the same number. 1 goes into 3 the same number of times that 2 goes into 6. All right, and then if I were to double 1 and 4, I would get 2 and 8. Okay, maybe I'm getting closer. Who knows? You know what I'm going to do? I'm going to maybe go Still don't have the same thing on the bottom here though. But what's something that 3 and 4 can both go into? I know they both go into 12. If I were to add two things that had denominations of 12, I could add them together and get something with a denomination of 12. So here's what we do. 1/3 is equal to something over 12. There is a fraction that exists that would make these two sides equal. Well, figure that out. What's 3 times 1 would be 12. How many groups of 3 is going to be 12? Well, there would be 4. So times 4. Now, if I do the same thing to the bottom, something to the bottom, I have to do it to the top. I'll show you why in just a moment. 1 times 4 would be 4. So it'd be 4 12ths. Okay? So I'm going to convert 1/4 into 12ths. 4 times 1 is 12. Times 3 is 12. 4 times 3 is 12. That means I have to do the same thing on the top here. Oops. 3 12ths. So 3 12ths. Hey, now I have the same denomination here. 4 of something plus 3 of something is 7 of that something. That something happens to be 12ths. So there's our sum of 1/3 and 1/4. Now here's why I was able to do what I just did. I essentially went 1/3 times 4/4 to get 4 12ths. Now, why is this side equal to this side? Well, what is 4/4? What's 4 divided by 4? 4 divided by 4 is just 1. Remember what we talked about in our first video. I multiply anything by 1, I don't change the value of it. I get back the same value. If I went 1/3 times 1, I would get back 1/3. All this is showing is that I multiply 1/3 times 1, and I get something equal to 1/3. 4 12ths happens to be equal to 1/3. You can always multiply by a fraction without changing the value of it if you have the same thing on top as you do the bottom. So like with 1/4, I multiplied that by 3/3 to get 3 12ths. 3/3, just like 4/4, is equal to 1. I basically went 1/4 times 1 to get something equal to 1/4. In this case, it was 3 12ths. So in this case, we had to multiply both fractions by something to get what we call a common denominator. Denominator is just the number on bottom. When I say a common denominator, I mean that we have the same denominator on the top and bottom. Okay. Probably we should do a few more of these examples here. Okay. How much time I got? Okay. All right, so what about examples where we don't necessarily have to change both fractions? If I had 1/2 plus 1/4. Well, let's see. I want a common denominator between these two. So what happens when we find the common denominator. We multiply the top and bottom by a number by something to get something else that's equal. Well, can I multiply 2 times a whole number to get 4? Absolutely. So here's what I'm going to do. I'm going to rewrite this as 1/2 times 2 over 2 plus 1/4. Keeping everything the same except for this part right here. Because that's the same thing as going 1/2 times 1 plus 1/4, which is essentially what we started off with. So this, what this becomes, see, 1 times 2 is 2. 2 times 2 is 4. 2/4 plus 1/4. That'd be 3/4. So sometimes you can scale 1 up and get the denominator you need without changing the other one. One more example, and then I have some practice problems for you. Now we scaled one of them up to get a number. How about scaling one down? Let's say I had 6 over 39. Let's see. Minus 10/13. Well, I noticed that I noticed that 13 goes into 39 3 times. So here's what I want to do. I want to take 6 over 39. I want to scale it down by keeping the same value here. So I know that 13 goes into 39 3 times. So I'll go ahead and do division because I know that makes 3 groups of something that are going to be equal to that. So 39 divided by 3 and 6 divided by 3. Doing the same thing to the top as I do the bottom here. So this is going to come out to 2/13. Now, if you need to, checking on a calculator, go 6 divided by 39, and then go 2 divided by 13. And you are going to get the same answer. So, 2/13, I'm just going to rewrite our original problem here, minus 10/13. Okay, I can compare them. They have the same denomination. So let's see, 2 minus 10, oh, okay, I'm subtracting a big number from a smaller one. So 10 minus 2 is 8. Oh, but I gotta make it negative here. Negative 8 over 13. And if you're wondering why I put the negative on top, I sometimes like to put it like on the side here or the bottom. It doesn't matter where you put it. It'll have the same value. As long as either the top or bottom is negative, you can put the negative on the side and they'll still mean the same thing. So that would be the answer to our original problem there. I think that's about all I wanted to go over in this video. Yeah. Okay. Now there's one more interesting example that I want to go over. 38 over 50, 8. Over 40. Okay. One more example. And we're gonna play around with this one a little bit. And so we are gonna get into some simplifying fractions a little bit earlier than I wanted to, but that's fine. One way to simplify a fraction is if I notice that the top and bottom are both even, what I could do is I could cut the top and bottom in half, divide them both by 2. What's half of 38? Well, it would be 19. Half of 50, 25. I'll keep the other one just the same, just you can kind of see step by step here. All right, so it's a little bit simpler now, but I know I can't multiply 25 times anything and get 40, and I can't divide 40 by anything and get 25, at least not evenly yet. Let's see. What if I can scale this one down, 8 over 40, enough to where I have a unit that I can scale up to 25. So we're gonna do a little bit of an elevator game here. We're gonna scale it down before we scale it up. I noticed that, let's see, 8 and 40 are both even. So let's go ahead and just continue with that here. 8 over 40, I'm gonna cut the 8 in half, get 4. I'm gonna cut 40 in half, get 20. All right, I'm gonna cut 40 in half, get 2. Cut 20 in half, get 10. All right, hopefully we can kind of see, yep, I have plenty of room here. I'm gonna do it one more time here. I'm gonna cut the 2 in half, get 1. Cut the 10 in half, get 5. All right, so I'm gonna just bring that all the way down because I didn't really change anything with that. So 9 25ths plus 1/5. Okay, well I am noticing that 25 is a multiple of 5. So I can scale 1/5 up to have the same denominator as this. So let's do that. I'm just gonna bring this up here. 19 over 25 plus 1/5. And I want to scale it up without changing the value of that 1/5. 5 times what is 25? Hopefully you answered 5. So times 5 over 5. Because if I multiply by 1 and change the value of it, that's fine. So my next step, 9 over 25 plus 5 over 25. Now I can combine those. They're like terms or common denominators, they're measuring the same thing. So 19 plus 5 is 24. The 25, oh, I was about to throw us off there, saying 50 there, but now it would just be 25. That would be our answer. Okay, so sometimes finding the common denominator isn't so straightforward. Sometimes you may have to finagle it a little bit. If you realize that 8 divided by 8 was 1, 40 divided by 8 was 5, to get that number earlier, great. You're in good shape and you're going to save yourself a lot of time on the ASVAB. If you look for the biggest factor they have in common on the top and bottom, and so you can scale that down quicker. All right, well, I will post some practice problems for this section here, and I will see you guys in the next video.